So, Hawkins developed theories about how black holes are formed and how they behave and where they can be found in the universe. We're going to just look at one of his theories, and probably the one that is most recognised and has been on kind of Family Guy and The Simpsons and things like that. So you will have seen this in some way. You might have seen it in films as well. It's been in a few films. Now, a black hole is a place where gravity has got so strong that it pulls matter down into it. So we know that gravity is a force. We know that it pulls down on us and keeps us on Earth. And if you imagine that millions and millions of times stronger, to the point where it doesn't let any matter escape, even light gets sucked into the black hole. Now, when anything gets too close to this black hole, it's just going to be sucked down into it and trapped forever. It's gone. If we put this into something where we can think about it, this is how I like to think about it. So imagine it is like a river, and you've got the river and you've come to a waterfall. Now, if I kind of was here, I might be able to swim away. I might be able to swim against the current and get away from the force that's pushing me down and over the waterfall. However, if I was kind of in this place here, I'm not going to be able to swim fast enough, and I'm going to end up going over the waterfall and into this bit here. And that's kind of like a black hole. As you get closer to the I don't know how to put it, the center of this black hole, the force that's pushing and pulling you towards it gets stronger. And if you get to a certain point, you can't get away, and you're just going to be sucked into it. Now, the edge of the black hole, the edge of our waterfall, as we've just said, is called the event horizon. And nothing can travel fast enough to get past the black hole, to escape the black hole's gravitational pull when you get past this point here. Here, you might be able to get away. You might be able to run, I don't know if you're in a spacecraft, you might be able to put your foot on the pedal, I don't know if they have pedals, or whatever, and zoom away. But if you get it too close to the black hole, and at this point you are going into that black hole. Now, we don't really know what is on the other side of a black hole. We've got theories. Some people think there's another dimension, or it goes to another point in space. Some people just think that you go and you get squished. And there's loads of different kind of theories about it. And we'll not know because we don't have the technology to travel through these things yet. Now, what you're going to do for this part is you are going to actually carry out a little bit of a demonstration to show how they're formed, because if you do something, it helps you think about it a bit more. I'm going to talk you through them. This is going to demonstrate how Stephen Hawking's theories about black holes and kind of show you what I am talking about. And once you've completed the inquiries, you're going to prepare a report on Hawking's theories and your own findings. So let's go through each one. The first one, you are going to inflate a balloon. You're going to inflate it to around 10 centimetres in diameter. You're then going to wrap it in loads and loads of tin foil. If you don't have this equipment, just visualise it in your mind or think about it with your hands. Kind of if the balloon was expanding, you wrap it up, then you can visualise that in your mind. So this represents a star, and the balloon is its hot burning core, and the layers of tin foil are all that gas around the outside. So star's a big flaming ball of gas in space. Now, stars die. So when stars reach the end of their life, then they run out of fuel to burn, they are going to go pop, basically. So you're going to pop the balloon with a pin. You are then going to squish all the layers of foil around the popped balloon. That's quite nice to do, isn't it? So you're going to squish all of it together, and you're going to see a change in shape and structure and things like that. Now, why would you do that? This shows how gravity compresses the star's matter around the collapsed core. So the dead star has the same amount of matter. Nothing's disappeared. The balloon's inside. It hasn't gone anywhere, but it is compressed into a tiny, tiny, small ball. And this means it has a greater density than the original star. This is how a black hole can be formed. So the dense ball of matter exerts a large gravitational pull on all the objects around it. The second inquiry you're going to do is to do with modelling how a black hole sucks matter into it. So if you get a kind of piece of fabric, I'll just use like a tea towel, and you get somebody to hold the other corners, and you put a ball onto it and you watch how it travels on your kind of tea towel. So the fabric space and the marble I've got here, or the rolled up piece of paper, or the rolled up piece of tin foil, or I don't know, bouncy ball, whatever you've got, is kind of an object in space. Once you've done that, you are going to put a heavier ball in the centre of the fabric. I don't know if you've got tennis balls, or maybe if you've got a ball of paper and a bouncy ball, any two types of balls. It doesn't have to be what I've got in here. How does the shape change? That's the first thing you're going to think about. So the ball represents a black hole, and it curves the shape of the fabric. And if you roll a marble across it, what happens? Is it act any differently to how it acted before? If you roll it quicker, does it change? Does it work better? All these things that you can explore. And you're going to notice how the heavy ball pulls the fabric down into a hole or a well. Once the marble falls into that well, it's pretty much had it, hasn't it, really? It's not going to get out of there. You can't shift space. So if you've got a tea towel, you might be tempted to go, well, I can because I just shake it and it fly up in the air. If you did that in space, think about I can't even imagine what would happen. It'd be catastrophic. So that marble is stuck in there and it can't escape. And that's basically how black holes work. Now, once you've done that, you do have a report to write on the original piece of paper. I suggest if you haven't been able to do these, then you think about them and you try to visualize them in your mind. Or you might be able to think of a different example to my river example. You might be able to think of something better than going over a waterfall. And if you can write about that instead, because the actual inquiry is quite a nice piece of writing and you can tailor it to what you've got at home.